Hey there, guys and gals. Don't mind the weird temporary setup. I'm you. I'm looking up at you, looking up to you. it'll change eventually, but you don't really care. You want to know about math. This unit, we're starting at the beginning of Unit 7. This unit really is going to take us back a long ways because in this unit, we're going pretty much back to 8th grade. And this particular lesson is going to be super easy and super simple. It's going to end up taking longer for me to sit here and tell you all these words almost than to actually do the thing. It's going to be very, very review. So we're going to kind of cover it quickly, hit a couple examples, and then we're going to be done with this lesson. Easy peasy. Let's jump in. So ratios and proportions is what we're talking about in this lesson. So what is a ratio? So reminding you, reviewing to you, a ratio is where we compare one number to another number, right? And we can write ratios a few different ways. We can write it as A to B, right, with a colon there, and you heard me say it out loud, but I'll just for the sake of clarity, and because we don't know what people's backgrounds are sometimes coming into my classes and all those things, but we say this as 2. This to that, right? We can also write ratios as fractions, so like A to B, A to B, right? And we can have equivalent ratios, right? That's a things that we can say. We can say that A to let me make sure I'm not forgetting something or something weird or whatever else, right? You can have equivalent ratios, which we're going to use here in a minute. You can say that A to B equals C to D. Now we've made a proportion, right? This is a proportion. A proportion is when you have equivalent ratios. The one kind of new thing that we're going to hit because we're in high school now, right, and not in 8th grade anymore, is that you can also have extended ratios. You can have A to B to C, right? You might you might see that in like a triangle, right, where we have a triangle, and you might say that these triangles are related in a ratio, right? We can have this as 3x, 2x. I'm really doing a bad job. Let me actually back up and look at what I'm saying. So 3x, this is the big one. So let's say this is 5x. I'm just putting random numbers in here as you picked up already probably. But yeah, and then 4x. So the ratio of this triangle is 3 to 4 to 5 or 3 to 5 to 4 or whatever else. And so you can find a similar triangle. We'll learn more about that as we push on by finding another triangle that has this same extended ratio of 3 to 4 to 5. That's kind of spoiler for the future. If the ratios of a polygon, of a shape, of an anything match, then those shapes are similar, which again we'll hit again later, which is also probably review. We just kind of the only real difference between this and 8th grade geometry math is that in this we kind of use big boy terms a little bit, and even some of your middle school experience may have been the same thing. So solving proportions, you've probably done a bazillion times, right? To solve proportions. Now, this is important, and I make a big deal of this in my pre-algebra class, and then when we hit it in Algebra 1 as well, that what we're about to do is cross multiply. Some of you have already started doing the math and whatever, but please listen really carefully because this is important to keep this separate, and that is if we're multiplying fractions like 3/4 times 2/5, we don't cross multiply, right? And I make a big deal of this because I'll ask in a high school class sometimes, how do we multiply fractions? So we may need to know that because we may start putting letters in things and whatever, and especially in Algebra 2 next year and all of that stuff. And so it's very important that we remember that if it's a times and we're multiplying, then you multiply just straight across, right? But if it's an equals, we've got a proportion, right? And so we're cross multiplying. So I want to make sure and elaborate on that to make sure we keep that separate because it's going to matter to do it correctly once we start throwing letters and polynomials and all kinds of crazy stuff in there next year, right? And so we want to make sure we're keeping that separate. So, oops, wrong button. All right, so let's solve this proportion. So to solve a proportion, you cross multiply. So this times this and this times that. 21 times x is 21x, right? And then 6 times 31.5, I'm going to go ahead and pull out my calculator for that. So find it, there it is. So 6 times 31.5 equals, I thought I turned the sound off on that. Sorry, y'all. I literally did it, but I think I got distracted and by the making sure I was in focus or something. Anyway, there we go. So, all right, so 189. 189. Now we've got a 21 times an x, so y'all know the drill. We're going to divide both sides by 21. Great. Now x equals divided by 21. Enter. So x equals 9. Right? Easy peasy. Now this one's a little bit scarier. We've got a couple of different x's and we've got a little binomial here. But we got this. This is easy peasy. You probably did this in Algebra 1, maybe even in pre-algebra, depending on your pre-algebra class and whatever else. So we're going to still cross multiply, right? So 2 times 4x is 8x, right? Just multiply those numbers in the front. Now this one's a little trickier, and I'm going to write it out all the way to make sure we know what we're doing. Because we're doing x times this, times all of that. Not x, that's a 5. You know, whatever. So 5 times all of that. So times x plus 3. And that's really important. That's an easy place to make a mistake, because if you don't slow down and think about it, you might just multiply the 5 times the 3 or just multiply the 5 times the x. And then that's going to be wrong, because what do we have to do with this? We have to distribute it, right? So that's really important. That's an easy place to make a mistake on those. So make sure you do it correctly. So we're going to bring down the 8x and bring down our equals 5 times x is 5x. 5 times 3 is 15. All right. We've got x's on one side and x's on the other side. So we've got to bring our x's together. I'm going to subtract the 5x from both sides. Remember, we're going across that equals. We change the sign. We do the inverse. Pretty straightforward. 8x minus 5x is 3x equals 5. Now we've got a 3 on there. It's multiplied times x, so we're going to divide by 3. Divide by 3. Whoa, what happened to that 3? I don't know. There it goes. So x equals 5/3. And believe it or not, that's it for that lesson. This is hardcore review, hardcore going back to middle school. Easy peasy. We got this. I'll see you in the next one. If you're one of my students, do your homework, please. If you're not one of my students, do your homework for your teacher and whatever else. And we'll see you later. Bye-bye.